All right. So silica slowly but steadily dissolves in seawater.
Whoa, you can barely see that.
Just like snow, slowly and steadily dissolves as it falls. And it builds up where it dissolves faster, or where it builds up faster than it dissolves, like a snow pile. Okay, let's go through this picture now. So I want you to pay attention and write down some key things that you're going to need to know to be able to explain this picture in 4 sentences. 4 sentences. So let's look. Look at everything that's up here right now. So on one side of the picture I have high productivity. On one side of the picture I have low productivity. And if we notice on the ground, which side has the ooze?
The one with high.
The one with high productivity. Okay, so that's something that we're learning so far. In order to have ooze, we have to have high productivity. With low productivity, it dissolves before it hits the ground. Now, why is this all on the surface? What do a lot of these need to survive?
Sunlight.
Sunlight, photosynthesis. Good. So as these shells fall, whether they be from plants or from animals, as they fall, we have ooze on this side. So let's look at the side of high productivity to see why this side might have high productivity. What does this say? Someone read this. Chad.
Silica organisms like cooler water.
Silica organisms like cooler water. So which side of this do you think has cooler water?
Right.
Probably the side with more productivity. So one of the reasons this side might have high productivity then is because it has cooler water. All right. Cool. That's called transference, guys. Now, cooler water is equal to more oxygen. So what is something else we might be able to say about this side? Has more oxygen. Also, plants tend to survive when there's a lot more oxygen, don't they? All right. Now this ooze on the bottom will mix with clay. And you learned yesterday what an abyssal plane is. Well, clay is a very fine particle. So it floats really, really far before it settles to the ground. That's why clay generally settles more in the middle of the ocean and less on the shore. It's because clay is able to float out. How about larger rocks? Are you going to have large rocks float out to the middle of the ocean? No. They're going to sink right away as soon as they enter the ocean. That's why you get the turbidites, those avalanches near the shoreline. But the clay will go out to the middle of the ocean and it will form a thin layer. So if you ever watch any undersea video where they show the bottom of the ocean floor, it just looks like this flat, silvery kind of ground. That's because a lot of it is clay with silica ooze or calcium carbonate ooze. That's what the floor is made of. And then basalt, I have 2 examples of basalt right here, is the most common ocean rock. It's a lava rock. Why do you think a lava rock would be the most common ocean rock? What is constantly being created on the ocean floor?
Volcanoes.
There's a lot of volcanoes, aren't there? What comes out of volcanoes? Magma. What does magma turn into when it hardens? Lava. There we go. Good job. You can pass those around.
What is it?
That's basalt. That is the most common ocean rock there is. So most of the rock that you'll find in the ocean will be basalt. It's a lava rock. Okay. So, can you guys explain this picture?
Yeah.
I think we can. So let's go on to the next one.
Hey, Mr. Do we have to copy that picture on the board? On the screen?
That's the same one that's on the board.
Do with this.
Pass it around.
Oh.
This is the same picture, guys. Okay, let's look at this one. This is the same picture as that one. Mine's just more colorful. So calcite, so now we're looking at figure B. Calcite dissolves beneath the calcite compensation depth. Yep. So you need to write these. So, what this is saying is that as calcite falls to the ocean floor, if it reaches 4.5 kilometers, which is 4,500 meters, below that it just dissolves. It can't survive.
All students are required to be in class.
So it just dissolves. So generally below 4,500 meters, you will not find calcite. However, there's exceptions to the rule, because there's always exceptions. Calcareous ooze can be found below the 4.5 kilometers if it is buried and transported to deep water. So if it is buried and then transported to deep water, and I'm going to explain that with that picture on the board rather than this one because it's a little bit easier. So I do want you to write these two down though.
It's going to be all on the website? Or?
Yeah.
Today?
Should be. Why, are you confused? Oh. Has anybody been having trouble with the PowerPoints? I've had like one person come to me and say they weren't able to pull them up or download them. And they're all Microsoft PowerPoint format, so they should all be compatible with most. So everything I post is either going to be PowerPoint, Word, or PDF. So it should all be in some format that you can open it up.
Where are you going to upload the film from yesterday?
I'll do that today.
And where can we go home today? 'Cause I wasn't here.
Today.
Well, like what page is it? I found
Mr. Brown's Marine Science class. Just type that into Google search and it will come up. And go under videos. All right, so let's take a look at this picture now. So let's start here. Let's kind of see what's going on in this picture. Because there's a lot of words, there's a lot of colors, so let's kind of explain it. So we have a ridge. What's happening in a ridge? What's being made? What? What's being made at a ridge, guys? Come on.
volcano.
It's a volcano, kind of, but what's being made? New ocean floor, new sea floor. Good. So what do we have underneath it that's coming up? We have magma. So as magma is coming up, is it going to warm the water around it? Yes, it is. It's going to warm this water. Well, it's good because calcite likes warm water. So generally, where the water is warmer, you're going to have more calcareous ooze or calcite. Because the magma is warming the water up. All right, so let's look at this. So I have calcareous ooze. I have photosynthetic calcium carbonate organisms all on the surface. As they fall, they collect on the ridges. They collect on the seafloor. Now, over time, let's say what we're making here, let's say we're making a 7-layer dip. We all have had 7-layer dip at some point.
Yeah, what is it?
It's like a taco dip. All right, so on the bottom of the 7-layer dip, what do you generally put? Beans. Refried beans a lot of times. Let's say on the bottom of our 7-layer dip, we have calcareous ooze. I know, it sounds tasty, doesn't it? Calcareous ooze. All right, so on the bottom of our 7-layer dip, we have calcareous ooze. Well, unfortunately, our pan for our bean dip is expanding. Because it's a ridge, and we know that ridges move apart. Well, over time, other items are going to fall on top of the calcareous ooze. So like on your 7-layer dip, don't you put something on top of the beans?
Not if you don't want it.
Well, it's not called a 1-layer dip, is it? It's a 7-layer dip. So a lot of times you put something on top. When you put something on top, you encase the beans that were on the bottom in. So with the calcareous ooze, as clay particles fall, along with other things, they enclose that calcareous ooze in. They make a layer above it. They encase it. And on this side, you can get silica organisms falling and encasing the calcareous ooze. So now we have calcareous ooze that's encased underneath other stuff. And there might be layers upon layers of this. Well, as these plates move apart, so let's look at this little red X. So over millions of years, this little red X moves apart because the plates are expanding. Plates are expanding, plates are expanding. Now look where it ends up. Am I below the calcite compensation depth?
Yeah.
How was I able to have calcite below this depth? What happened that allowed it to be under this depth? It was carried because it was encased in something else. It was transported because it was enclosed underneath other items. So calcite can go below 4,500, but it has to be encased in something and transported. So in this case, it was encased in clay, and it was transported because of the seafloor moving. All right, how are we doing on that?
What does it say right there in between the blue dots?
Oh, I'm getting there in a moment. Is everybody good on this part, though? All right, so in the ocean, you have various areas where upwelling occurs. Upwelling is a process where you have deep water that rises or upwells. You guys all know what a well is, right? A well is where you take water from underneath the ground and pull it up. Well, we have upwelling, so that deep water rises to the surface. Well, is the water colder or warmer at the bottom? It's cooler, isn't it? So if you have cold water rising, which kind of organisms prefer cold water?
Fish.
So what are we going to have a lot of in areas where you have cool water? High silicon organisms.
What is that? Is it like seashells on it? Like
Seashells?
Remember what silica organisms were?
no.
Diatoms and radiolarians.
What are those?
All right, let's take a quick latitude longitude lesson. So I need everybody listening.